This is section 11.6, day 1. And today we're going to start talking about the areas of regular polygons. So that means any shape essentially above a quadrilateral, since we have done triangles, which are polygons. We've done all the quadrilaterals, kites, rectangles, squares, trapezoids, all of those. So now we're talking about anything bigger than that. So like this has got 6 sides, or a pentagon, any of those shapes that have more than 4 sides. And in order to do that, we have to talk about a couple of new vocab words. One is apothem. You've probably never seen that one before, but we're going to start talking about the center. The center is where the center of the circle is. So for us, in this example, would be P. The reason we're talking about that is because we're going to talk about the central angles, and we need to be able to name those. And radiuses, and all radiuses come out of the center. So a radius here would be PM or PN. The central angle, we'll tackle that one first since that's something we know, is just an angle with its vertex at the center. So a central angle here would be MPN. And I'm using M and N and not Q because Q actually stops right here, which is not quite on the circle. So for it to be a central angle, we need the ends to be on the circle, and we need the vertex at the center. So here would be MPN. Or you could name it backwards, so you could do NPN. Apothem is a new word for us. It is from the center of the circle to the midpoint of one of the sides of the polygon. So this is called the apothem. It is not a radius. If you look real close, it's a little short of that. Radiuses go from the center to the circle. This one is stopping. It's got a little bit of a gap, so it's kind of short of that. So it's shorter than a radius, and its name is an apothem. Today we're going to be doing a lot of just identifying and finding the measure of pieces in here before we tackle the area. So ABCD is a regular pentagon. That's a big deal. It means that all of the sides are congruent. And then it's kind of hard to mark this one because there's all that stuff going there. Also, all the angles are congruent. So angles C and D and E and A and B, those guys all equal each other. And the only kind we're going to do are going to be regular. So they're always going to be regular. We're going to find each measure. So the measure of AFB. So from A to F to B. So that is a central angle to this pentagon and to this circle. There are several central angles. Here's another one. Here's another one. Here's another one. And here's the last one. So however many sides you have, that's how many central angles you have in your picture. So to find the measure of just one of them, we're going to take 360, which is all the way around, and we're just going to divide it by the number of sides. So for us in this picture, it's a 5. So 360 divided by 5 gives me 72. Next up, we're doing AFG. So A to F to G. So it's actually cutting this. We had found out that this whole thing is 72. AFG actually cuts that right in half. So we're talking about just that chunk right there. So we would take our 72 and cut it in half. So that little angle is 36. And why we're going to use that, when we get to the end of this lesson, we'll be using that a lot. So this is that triangle. This is 36. And since it's a right triangle, we're going to be able to use SOHCAHTOA, which is awesome. It's been a while since we've done that. And we'll be able to use Pythagorean's theorem. So a squared plus b squared equals c squared. A couple of theorems and ideas we haven't used in a little bit. Last one is GAF. So G to A to F. That would be in this corner. All the angles in a triangle add up to 180. So if that's 90 and that's 36, I just subtract 90 and 36 from 180 and I end up with 54. So our job is to be able to find those angles because then we're going to use them with some SOHCAHTOA. So here we've got one more picture. I've got a square inscribed inside of a circle. So identify a radius. One radius could be, this is supposed to be a Y if yours didn't fill in there. This is PY or PX. I'm going to name the other two. It could also be PZ or P, that's a W. A central angle, one of them, there are 4. Well, there's probably lots, but 4 in our square. So I'm going to do XPY. That's one of our central angles. We'd also have this one and that one. So we'd have all of these guys. I'm just going to say the one that was there, so XPY. The apothem would be QP. and then find the measure. So we're going to figure out how much each of these are. So from x to p to y, so I've got 360 again, divided by my 4 sides of my square, means that each of those are going to be a 90. X, p to q, so now I just want half of that, so that's 45. And the last one, from p to x to q, I'll just draw that triangle again. We've got a 90. We just figured out that was 45, which means that angle also has to be 45. All right, so now let's use that idea to actually find the area of a polygon. The formula for area of a polygon, right here, A being the apothem, and S is the side length. Be careful when you write S in your formula so it doesn't accidentally look like a 5. But your area is 1/2 A apothem, N number of sides, and S side length. So A is apothem, N is number of sides, and S is side length. So apothem is inside, number of sides is how many, and S is on the outside of the shape. So area equals 1/2 ANS. So 1/2. My apothem is 6 square roots of 3. Don't be scared of that square root. We're just going to type it in our calculator. Number of sides, I've got 1, 2, 3, 4, 5, 6 sides. And then side length is what's on the outside, and that is 12. So we just get to type that in. Again, don't be scared of that root 3. We're just going to go 0.5, which is a half, times 6 root 3, times 6, times 12. So about 374.12 centimeters squared. You're doing area, so don't forget that label. Today is just introducing you to some vocab, how to find some angles, and then how to do pretty straightforward areas for today.